Thank you. Okay. It's recording now. Thanks again. All right, so 14b-1, that is odd even function. We had already done the first page. All we needed to do is the last page, 11 through 14. So people at home, if you could scan that or photo it and then email it to me if you haven't done so already, that'd be awesome. I'm going to come around and check around here, which I'm sure is going to be totally exciting on the iPad recording and here. I shall return. Okay. Oh, by the way, did I check off those 4 random ones for the front ones to anybody? 3, 4, 5, 10. Oh, right. Just do it tomorrow. Or not tomorrow.
Wait,
I did. Yeah.
Well, I didn't do my
Oh, I see. Just out of curiosity, how many people have the back done? We got 2, 3.
I did my work on different. That's what this one is. I did my work. This whole thing was due Monday.
Well,
that's a
tell you what,
issue.
let me check off the 4 things that I went through the answers on those yesterday, right? Before, or did I not? That's bad. All right, let's do that. Then let me just check off the 4. I probably totally second.
yeah, I'm pretty sure you said
Yeah,
back.
I was doing
Okay.
You already checked this side.
Okay, well, I should do 2 parts.
Oh, Mr. Thompson.
There we go. If you got the back, yeah, then hang on to that. Thank you very much for that.
Mr. Thompson.
If you have the entire back done, you have no homework for the weekend. Yeah, yes, sir.
What did you say wasn't Monday? Was it the ninth? Is that what you're saying?
I'm starting to think, yeah, I think I might have sped, because this chapter is so similar to what we're going in pre-calc that I think I swapped the 2 of them in my mind. Tell you, update. There were 4 problems on the front that we had on 14b-1, number 3, 4, 5, and 10, which we did not check off immediately. We checked off the other ones. I'm just checking off those today. So if you haven't sent those, send that. I don't know if that was good English or not. But I'm going to make the entire back page due on Monday. I'm also going to give you a new worksheet that I think I'm going to make that entire thing due on Tuesday. Does that make sense? All right. I will give that to you in advance so that you can start looking over it. I'll start giving you notes on that today, but we'll go from there. Let me read off answers for 3, 4, 5, and 10. And we can go through any of those that you'd like. Number 3, oh yeah. Where's my marker? There it is. We're going to have to do a, oh right. One of these days I'm going to remember all of these tech routine things. Just in time for everybody to come back, actually. So let's see, number 3, the answer is negative 0.09. Number 4, the answer is negative 1.31. Number 5, the answer is positive 1. And number 10, the answer is positive 0.69. And it repeats. Okay. Did everybody get the list of formulas in your notes? Like if anybody's heard?
4 master ones?
There were not those, but when you had the backwards version, let's say, hang on a second, that's a horrible marker. Let me get a decent marker. Now I'm talking more about this. If you have the, let me double check, so I know what you're seeing at home. Hi, Mr. Jackery. I'm interesting that you're joining us, but this is Algebra 2. Just so you know. So you're welcome to sit in on it. If you want Algebra 2, by all means, but you need not. So lovely to see you. Anyway, moving on. not Nick. Oh, who is that? Oh, is that Courtney?
Yeah.
Oh my goodness. Hi, Courtney. You got a picture of Nick coming up. So, just saying. No offense to Nick, but you're a lot better looking. So, just moving on. Let me get the thing set up here. So here's the things I was looking at, and hopefully, oh, that's a crummy marker too. Pardon me, all the markers are dying on me.
How many markers do you have left?
Not a heck of a lot. So, let me see. Blah, 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 blah. Okay. Let me know if you can see this. Oh, that's a nice dark one. Sine of, normally it's sine of 90 degrees minus theta is equal to cosine of theta. So we got a list of those. There were two separate lists I gave you of these. This, by the way, is called a complement. It's the complement of theta. Like whatever we'll add with theta to be 90 degrees. Okay? So what happens if this thing is backwards? Well, if it's the sine of theta minus 90 degrees, and again, note that this is backward. Then, can I read this at all? Or kind of, sort of? Okay, let me scoot it up a little bit. Kind of, sort of? Is that better? Or, oh, wait a minute. Is that better? Can you give me a thumbs up if you can read it? Okay, most people can? Nice, thank you. So, I've got this teeny little postage stamp of a screen, so I'm just sort of taking that in faith you can see this. Anytime you want to switch a subtraction, you can pull out a -1 and then flip it around. Normally that would make things really awkward, but sine is an odd function, which means if you put a negative in the input, it'll make the output negative. So it'll be sine of negative sine of 90 minus theta. And if you remember from up here, the sine of 90 degrees minus theta is really cosine. So it's negative cosine of regular theta. Okay? So that's the kind of, there was a chart of 6 of these that I gave you, sine, cosine, tangent, for the times when it's backwards. So the sine is equal to negative cosine is equal to regular sine, etc. If you do not have that, let me know. Email me, and I'll see if I can give you a replacement. But for now, let's go through some of these problems. Does not erase well. That's better. So, questions? And you can jump on chat. I do have the audio up, so I should be able to hear you. But feel free to use chat if you want to. So, questions? 3, 4, 5, or 10? Nobody? Seriously? Yeah, let's do 10. And I see number 5 on the list there. Let's do number 10 first. Number 10 looks like this. Let me call this up real fast. If cosine of negative theta is equal to negative 0.69, find the sine of theta minus pi over 2. Nate, what is pi over 2 again? Somebody remember? We go. It's 90 degrees in radians. Right. Question. Is this forward or backward? It's backward. It's supposed to be the 90 degrees minus theta first. So let's play with this a little bit. Could somebody tell me what cosine of negative theta is? First of all, is cosine even or odd? Well, cosine is even. What does that do to negative inputs? Does it switch? I mean, if they switch the input, does it switch the output or no?
No.
No, it does not. It's exactly equal to regular cosine of theta. So I'm just going to rewrite this top one. If cosine of theta is equal to negative 0.69. Does that make sense? It makes the problem a little bit easier. If the cosine is negative 0.69, then let's find this thing. The sine of this. How do you fix it if it's backwards? Do you remember? How do you switch a subtraction problem? Yeah. Pull out -1. And then you can switch this to pi over 2 minus theta, just like normal. What does sine do when you put a negative in the input? Is sine even or odd? Okay. It's odd. So what does it do? When you switch the input, does it switch the output or no? Yes, it does. So this will become negative sine of pi over 2 minus theta. So we're getting closer. I know that cosine of theta is equal to this thing. Can anybody tell me what sine of the complement means? Yeah.
Isn't that just cosine?
Yeah, the sine of the complement is the complement sine, also called cosine. So remember there's a negative in front, so it'll be negative cosine of regular theta. Look up here. The regular cosine is negative 0.69. What's negative cosine? Anybody? Positive. And that's how you get that answer. It's tedious. There's like 2 different things where you have to figure out, okay, well I guess 3. You have to figure out if you put a negative in sine, is it even or odd? If you put a negative in cosine, is it even or odd? And what happens when the thing is backwards? You have to pull the negative out. Does that make sense? And I think, Sam, you wanted number 5, is that right? Yeah. Alrighty. So number 5, let me switch to this screen again. Come on, you little whippersnapper. Number 5 looks like this. If secant, has everybody got this? Okay. And it's going to be recorded, it'll be in the video too if you lose it. And by the way, you can all watch the video from, it's not copyrighted or anything. Number 5, if secant of negative theta is equal to -1. Let me stop right there. Take a look up here. Can we tell me what secant is? Back up. What is secant just in general? Reciprocal of cosine. Right. This is based on cosine. This is 1 over cosine. As a consequence, is secant odd or even? Yeah. It's even. So if you plug a negative inside, what does that do? It stays the same. So in other words, secant of regular theta would still be -1. It does not change anything. Does that make sense? All right. So now I'm going to throw away the garbage version and get the nicer version here. This is going to be our starting piece of info. If secant of theta is equal to -1, what they wanted is, what is cosecant of theta minus pi over 2? Question. Before we jump to conclusions, is this forward or is it backward? It's backward. What's the cure for that?
Pull out -1.
Right. If you pull out a -1, and then this thing will switch to pi the other way around, One last question. What is cosecant? Spencer? Just in general, what does cosecant mean? Reciprocal of sine, yeah. Is that odd or even? Odd. So what does that do when you have negatives in it? Does the answer stay the same or does it switch? It does. Odd, okay, quick 30-second thing. You missed my story about somebody slashing, right? Okay, here's the story of slash. Okay. If something is an even function, I'll just put this off to the side. An even function, it's sort of like how do you handle adversity? If somebody gives you a negative input, what sort of output do you give them? If you are even-tempered, if they give you a negative input, it's the same as if they gave you a positive input. You're just nice and even-tempered. Mr. Coughlin, somebody just gave you $50. That's nice. Mr. Coughlin, somebody just slashed your tires. That's okay. Even-tempered. So no matter whether you plug a negative or a positive in, it'll give you the exact same answer. Like if this is 0.28, this will be 0.28. So what about an odd function? An odd function, if you go negative on its input, if you plug negative experience into it, it goes all negative on you. Example, Mr. Coughlin, somebody just gave you $50. That's nice. Mr. Coughlin, somebody just looked at you funny. I'm going to blow up their car after school. By the way, kidding, totally kidding. But if somebody plug in a negative and they go all negative on you, this is the sort of the revenge problem, if you will. Odd functions take revenge. Even functions turn the other cheek, if you will. So, if we know that cosecant, also sine, are odd, then making the input negative is going to make the output negative. It'll be the exact same thing as if they had taken the negative, version of this thing. Okay, take a look up here. Does that kind of make sense? It looks like, I mean, ignore this. What happens when you put a negative in cosecant's input? Well, it's odd. So if you make the input negative, it'll make the output negative, and everything else stays the same. Okay? So, can somebody recognize this? Not the negative, but what is cosecant of this complement? What is that called? Cosecant of a complement. Go.
Is it just, sorry, so cosecant is for sine.
And sorry, I'll tune you guys back into and staring at a bunch of numbers. So go ahead.
Is it cosine?
Close.
Sorry, secant.
Secant. Yeah, this is secant. Of what? This is the complement. It's kind of like the cosine, well, the sine of 10 is equal to the cosine of 80 degrees.
So theta?
So yeah, it's plain old theta. Does that make sense? Everybody know? Does that kind of make sense? So, actually name the cofunctions for me. What's the cofunction for sine, Spencer? Shh, don't even, and by the way, that's not right.
That's the point.
Okay, so what's the cofunction of sine? I'll give you a hint. Co stands for complementary or complement. Remember in geometry? So two angles are complementary if they add up to 90. So, and there's actually a word, it's hidden in the word. What would be a contraction for complement sine? Just take a wild guess.
This is a lot when I was going.
You did, but it'll actually make sense in about 30 seconds. Let me write it. Oops. Complement sine. What does it say?
Cosine.
Bam.
That's crazy, dude.
That's common. Everybody else had the thrill of discovery last week, so I had to give it to you. So complement, in other words, a complement, for example, if you have theta is equal to 10 degrees, its complement, the complement of theta is 80. It's whatever adds up to 90. Does that make sense? So these two are complementary because they add to 90. What is, actually, Spencer, tell me, what's the complement of 20 degrees? 70. How do you get that? Like, what mathematically did you do?
90 minus 20.
Exactly, you did 90 minus 20. Whenever you see 90 minus theta, that's automatically a complement. So the sign of a complement is called the complement sign, also shortened as cosine. Guess what the complement of tangent is? It's actually another function we've heard before. Cotangent. That's where the name came from. It's complement tangent. And then secant complement is cosecant. Bam. So if you have the, where were they? Here we go. The cosecant of the complement, the co just cancel each other out and make secant. So the answer is negative secant of theta. And now we can finally finish the problem. If secant of theta is -1, what's negative secant? Jeff.
Oh, it's 1.
It's positive 1. And that's how you get that answer. Does that make sense? Y'all listen to them, making sense so far? Any questions? I want to make sure I don't leave you all behind in the dust. Any other questions on homework 14B-2? Dash 1. Going once. Twice. Sold. All right. Now, people at home, if you could send a photo, if the front page was not complete last time you sent a photo, just send a photo with everything included, including 3, 4, 5, and 10. If you already sent it with them completed, you don't have to send it to me again. I'll just give you another 3. And the next assignment is going to be finishing the back page. Okay. The notes for that should be online on the web. Let me double check my web YouTube channel here. I do have, yes, it is up. It is from, it says Algebra 2, 2021, May 6th. It says solving with master trig formulas. So it is on there, so go ahead, and nobody's viewed it yet, so go ahead and view it. I'm sure it'll make brilliant viewing. So I got your notes, y'all. I want to start you off on a new topic. Again, your assignment, and I'll give you some time to work. Gentlemen. Your assignment is to finish this worksheet on the back. The main trick, again, is to get everything in, like if you have like 2 different functions, like tangent and secant flying around, get them all in terms of tangent or all in terms of secant. Make sure it will be in same function all the way through. And then watch the video for details. I need to give you a few formulas. The first one, you have to kind of take on faith. The proof for this is long and tedious. So if you can just take it on faith, I can spare you the 20-minute proof. But here's a quick example. I'll just do this. Okay, people at home, can you read that? Okay. The sign of A plus B. A lot of people would assume that this is sine of A plus sine of B. I wish. It would make life a lot easier, but that is not correct. There are a lot of times when addition will destroy our expected rules. You remember this one? A plus B parentheses squared. Guess what everybody wants to say this? Yeah. Everybody wants to say it's A squared plus B squared. It is not. It is square the first, double the product, square the last. That plus sign messes up lots and lots of things. It's rare when you can get something with a plus sign actually works. Here's the actual formula. Sine of A, cosine of B, plus cosine of A, sine of B. It took a long time for people hundreds of years ago to find this formula. We're just enjoying the fruits. So why would we need it? Well, I'll show you two reasons. First of all, this not only works with addition, it also works with subtraction. By the way, subtraction and addition are pretty much the same thing, just forward and backward. Do me a favor, see the plus here in the A plus B? Do A plus or minus B, and then do the same thing over here. Here is something that this problem is just designed for. First of all, can anybody tell me the definition of a common angle? We've been playing with them for like a month. Yeah, sure. Yeah, any multiple of 30 or 45 or 90 degrees. Okay? And you could even say any multiple of 30 or 45 degrees. What if I gave you an angle that was not common, and I said, give me the sine value? What would you have to do at this point? Every common angle, you should be able to give me an exact answer for sine, cosine, tangent, cosecant, secant, cotangent. Well, what if I give you like the sine of 10 degrees? What's the only thing we can do? Feel free to jump in and I'll do. Like, what's the only way to, if I say sine of 10 degrees, and I say put it on a test, how? Can't use 30, 60, 90 triangle. Can't use the unit circle. Can't use 45, 45, 90. It looks like we're doomed. There's really only one thing to do, and I'm not terribly fond of it, but go. Calculator. Yeah. Plug it in a calculator and you just get a decimal approximation. It's not exact. So it's really sad when that has to happen because we lose an exact number and we get an inexact number in its place. What if I ask for this? The sine of 15 degrees. Common or uncommon, first of all? Becca. Not common, correct. It's not a multiple of 30, and it's not a multiple of 45. The thing that fools people is it's a factor of 30, and it's a factor of 40. It goes into 30 and 45, but it's not a multiple. It's too small. So if you count by 30s, you'll never count 50. So it looks like we need a calculator for this, right? But I want an exact value. On the test, if I say, give me the sine of 15 degrees, and I want the exact value, no credit for decimal approximations. The first reaction is people's eyes get big and they say, like, I can't. It's like, you're expecting me to do something, you know, the angels of fear to do. Well, watch. I'm just looking at this. Is there any two angles that you could subtract that would get 15? Nice angles. Not like random, like 47 minus that. Get it? 45 and 30 would work beautifully. Now you say, well, okay, great. That'll just give me sine of 15, won't it? Isn't that just the same horribleness? We have a formula. Now be careful to use the subtraction version. So, say what? Let's see if we can actually get this thing to work. Megan, can you read this here? Megan, can you see? Oh no, oh great. Awesomeness. Hang on a second. I'm gonna have to turn off chat right now because for whatever silly reason, Google doesn't want me to have a picture of the screen. But, is that like here? Can you see that a little better? Okay, well, that's going to be kind of doomed then. Let me write it bigger. Let me go down here. The sine of A minus b is equal to the sine of a cosine of b minus cosine of a sine of b. And I probably went off screen, didn't I? Can you still see that? Okay, there's some people who can, some people who can't. Megan, any better or no? I'm gonna. Can somebody just donate like a $15 million to get a new Wi-Fi system for cigarette? Man alive. Hold on, I'll get as close as I can. Any better? No, yes. So right here. Everybody give me a thumbs up if you can read this clearly. Okay, go 1, 2, 3, 4, 5. Courtney, can you read this or no? You can read it. Okay, Megan? Any luck? Oh dear. Are you on your phone or no? No luck? Oh, you're not done. Okay. Well, I feel for you. All right, I tell you, I hate to do this to you. You'll probably have to look at the YouTube video a little later. It is a lot clearer than this, and I need to move this out of the way so I'm not blocking. So let me just finish this problem here. Sine of a minus b is blah, 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 blah. Pretend that a is 45 and b is 30. This is what we're going to get. Go ahead and write this down. Down on the back. Tune in. The sine of what? Abby, I'm down here. What do I put here?
45.
Good. Sine of 45. Then the cosine of what?
30.
Good. Keep going.
Minus cosine of 45.
Uh-huh.
And sine of 30.
Correct. And then the sine of 30. This, by the way, is a case where you'll need, you remember we did all those drills to get you better at the multiples of 30 and 45? Here's where they come in handy. If you can pull these off the top of your head, it'll speed up these problems a lot. Can anybody tell me the sine of 45 degrees? Yeah.
Square root of 2.
You got it. Radical 2 over 2. Sorry, I'm going low here. If my laptop's in the way, let me know. What's the cosine of 30? Anybody know? Yeah. Radical 3 over 2. What is the cosine of 45? Very clear. Radical 2 over 2. Identical to sine. And sine of 30, Becca. It is 1/2 because it's up a little. Okay. Let's do some math here. What's radical 2 over 2 times radical? Because you got to multiply before you subtract, do an order of operations. I'm going to scoot this up here. Actually, I don't want to make you all seasick at home, but I'm going to move this thing over here. I hope you can see this. Everybody see my hand over here? Okay, I hope. So I'm going to write this again. Radical 2 over 2 times radical 3 over 2 minus radical 2 over 2 times 1/2. All right, math people, go for it. Will, help me out. What's a radical 2 over 2 times radical 3 over 2? What's a radical times a radical? Don't work too hard. A radical. So what's radical 2 times radical 3?
Is it just radical 2 times 3?
Correct. So radical
2 times 6.
6. There you go. Over what? 4. That's all you can do. Minus, do the other one while you're at it.
So radical 2 over 4.
Yeah, and we have a common denominator. They're both 4s. So put them all over 4. Can they do radical 6 minus radical 2? Are those like terms? No, they're not. They'd have to be like 3 radical 6 minus 2 radical 6. They'd have to be the exact same radical. Kind of like, this would be like x minus y. Can't do anything. Just put them next to each other. Radical 6 minus radical 2 all over 4, that is the sine of 15 degrees. Does that make sense? That's how you do it. So I am going to hand out the worksheet. You do not have to do it yet. I'm going to leave the screen just for a second. I'll be right back. 14C-1. Some of these are pretty exotic. I'll give you a hint on number 1, for example, because it can really bust some people's brains. So, and again, I just emailed this to y'all, and sorry, I'm going to make y'all seasick again. Does everybody need to, I'm sorry, was everybody taking notes on that part of the screen? Let me know. Okay. Let me know, and I'll fix that. So, okay, I'm looking on the, oh, and somebody was chatting, sorry. All right, got it. Number 1 on 14C-1, it says the sine of negative 105 degrees. Let me do some erasing here. And I want to see if we can do that. Negative 105, how on earth do you do that? Well, the trick is if you can find 2 nice angles that add or subtract to make negative 105. I would suggest subtracting, actually. It'd make it a little better, a little easier. Let me see what the screen looks like. Yeah, kind of so. So here's the problem. Sine of negative 105 degrees. You can use any, by the way, you can use addition too. Can anybody think of any 2 angles, positive or negative, doesn't matter, that you can use to combine to make negative 105? Make sure they're common. Yeah. 135 and 30. Now I would add a couple things. This would make positive 105. So what would I do?
You could just do, negative 135.
Exactly. Flip around. So 30 minus 135, or plus negative. Yeah. So the formula is going to say this. Sine of 30, cosine of 135 degrees, minus, whatever this is, cosine of 30, sine of 135. Can somebody do that for me? Mary Claire, start me off. What's the sine of 30? 1/2. What is the cosine of 135, Spencer? I'll draw you in a circle. First of all, is it positive or negative over there? It's a negative. So negative what? What's the only fraction for multiples of 45? Say again, sir? Sort of. That's part of it. Square root of 2 over 2. Yeah. Minus, let's jump in here. Rainey, what is the cosine of 30 degrees? And you can unmute if you want. Close. Here's, that's for tangent. Okay. Is it left, right, or up, down? For cosine. Left, right. Is 30 degrees left, or is it right? Like just, if it's here. So it's to the right. A lot or a little? A lot. So there are only 2 fractions for multiples of 30. Radical 3 over 2 and 1/2. What was it? Got it. And then can somebody give me the sine of 135? Josh. 135 is here. So where's the sine of that? I'm sorry, say again?
Is that radical 3 over 2?
Close. Radical 3 over 2 would be a multiple of 30. Radical, multiple of 45, which 135 is. What's the only fraction that works there? Radical 2 over 2, got it. Can somebody give me the final answer? Yeah, I'm sorry, go ahead.
Wouldn't the first radical two be the negative?
Where am I? Oh, cosine 135, thank you. Saved my bacon there. Sorry, cosine of 135, negative. Oh, thank you. This, everything else okay? This should be positive for cosine, this should be positive for sine because it's up. Can somebody give me the final answer here? Multiply for me. Shelley, help me out. What's this gonna be?
Negative radical two over four.
Negative radical 2 over 4 minus,
Radical six over four.
got it. So you can just do negative radical 2 minus radical 6 all over 4. And there's your sine of negative 105. Does that make sense? Yeah.
What should we do for the ones that are tangent?
Excellent. For tangent. For now, skip those. Actually, it's not due yet anyway.
Yeah.
But do the sine and cosine if you want to do those. On Monday, I'll give you the tangent addition formula, and then you should be able to do it from there. Make sense? Rest of the hour is yours. Not a heck of a lot of time. But you can go ahead and work on the last page of 14B-1. People at home, God bless your attention and your health. Stay warm. You're probably a lot warmer than we are because this room is a meat locker right now, but that's okay. We're offering it up for you. So, yeah, take care. God bless. Talk to y'all later. No worries. Thanks. Thank you. Oh, yeah. And off we go. And, okay, for those of you listening at home here, we just said goodbye to you in real life. We're saying goodbye to you on virtual now. Talk to you later.